Terem. Terem.
Hi everyone, my name is Simon from Terem, and today I'm going to talk to you about continuous integration and continuous deployment. Now, if you've worked in the software industry, you may be familiar with these terms, but what we often find, and what I've found in 15 years of software development experience, is a lot of teams don't give this prioritization or even neglect to do it altogether in favor of other priorities. So I want to talk to you today about why these things are so important and why they're important disciplines. Before I get into that, I just want to talk about how software is changing the world. No matter what industry you're a part of, software is a big part of how customers are acquired, how products are sold, and it's every important company, every big company is definitely using software, and of course smaller companies are as well, although they're probably more likely to buy software than build it. So what is good software? What makes software good? At a high level, I think good software takes advantage of the fact that software gives us superpowers. You can do things very quickly, you can do things very easily, and using software well, building software well, means you're taking advantage of those powers that you can get through software. In many ways, software engineering is a bit like engineering, but if you think of traditional engineering where you're building something physical, that physical thing, say it's a bridge, is not likely to change materially over its lifetime, over its usage. Unfortunately, with software, it's quite the opposite. Most software we use, most software we build is updated quite frequently. It's not static, it's not a thing that's put out there and just keeps on working. It's usually updated. So I like to think of software engineering sometimes as gardening. You need to mow the lawn, you need to cut the weeds, you need to water the garden, and if you neglect a garden, it goes to ruin. The default nature of software is very much the same. If you just continue to work on it without correct processes, without the right health checks, it will also go to ruin. The other thing I want to say on this is I've seen some terrible disasters with software over the years I've worked with it. I've seen things blow up in production, things go down for days or weeks on end, and that's the sort of problem we want to help you avoid with our talk today about continuous integration and deployment. Software done well is, easily put, highly agile. That means simple, repeatable processes that automate the mundane or manual work that can be automated. There are a lot of ways to measure whether your teams are doing software well. One of the easiest measurements, and one that really presents a threat to software integrity if it doesn't exist, is measuring how easy it is to integrate your software and how easy it is to deploy it. And that's where the terms CI and CD come from: continuous integration, continuous deployment. It's really asking the question of how long does it take for your teams to integrate new code, and how long does it take for your code to go from being integrated to being deployed. And if you can measure that in hours, days, that really gives you the answer you need. Done well, these processes take very little time, and they're very easy to repeat, and they're processes that your team has a lot of confidence around. Now, there are reasons why teams don't implement these processes, why integration is not continuous, deployment's not continuous. I would say the top reason is that testing is not done enough. There's not enough testing. So what ends up happening is changes are made, and those changes may or may not break things, and because you don't have the test automation to tell you right away or after a short delay whether or not something's broken, your team can't know. And if you then have low confidence over your new code not breaking something, well then you obviously won't have confidence about putting it out there. So that's the top reason, is we find a lack of test automation at the start of a project really hurts these processes. Now, at the start of a new development, it can seem like this is all a bit mundane, it's a waste of time, and the pain is only felt later on. So it's really important to take these disciplines and implement them early. And if your team hasn't done that, you can always go back and fit them in, and do so gradually to catch up with where you need to be to have confidence around your software. Another reason why this doesn't happen is there can often be risk aversion around high agility. Now, you may work in an industry where you're very risk averse. It's just the culture that you're in, and that's okay. Some industries need to be risk averse. They operate in areas of safety. Human lives can be at stake, so there's definitely situations where being agile is a bit scary, but I would argue that being agile with your software processes doesn't mean you have to change your company culture. It just means that you have reliable processes and you can still have your manual controls around that, but it's really important to automate anything that doesn't need to be manual to avoid human error being introduced. So we do see a lot of risk aversion, but honestly it ends up being riskier to not do these things. If you don't have the right automation, if you don't have enough tests telling you something's broken and blocking it from being deployed, you're more likely to break something. And instead of many rapid small releases which are safe, you end up piling up your releases into these large chunks where it's kind of all or nothing, and when you put it out there, things may break, and they're quite likely to break because of the magnitude of the change. So really by being agile, you're being less risky, and by grouping up your changes, slowing it down, taking things easy, making sure it's safe, you're actually making it more unsafe. The last reason I want to mention why these processes aren't followed is sometimes the team doesn't have the right expertise. So maybe these practices haven't been followed in the past, and now that teams are looking to introduce them, they don't actually know how. And that's an area where obviously Google is your friend. There are people who've done this before, but also you might want to specifically look at adding a DevOps person to your team, or a automation engineer. These are specific disciplines that can help you with these areas. So talking first about continuous integration, when that's not done well, when you're not integrating continuously, it can take days, weeks, or months to integrate work that's being done. Work is done in large chunks rather than smaller ones, as I previously mentioned, so things get risky, and when it comes to integrating, it becomes a very long, cumbersome process. You run into conflicts, things are more likely to break, and what ends up happening as well is you have no business confidence that a new version won't break something because this integration isn't done continuously. When done well, you can integrate code in under an hour, just with smaller processes around its integration. You can integrate code multiple times a day, and you have high confidence around this. Done well, your team owns this process. There are guidelines that they follow. There are rules they agree to and maintain within the team. And your team has the right disciplines in terms of quality assurance and peer review to make sure this is a safe process. So before you can get to continuous integration, there's actually some prerequisites. The first prerequisite is you need to have the right task breakdown. If your tasks take weeks to complete, you can't really integrate continuously. So you need to agree on a maximum size of a story that your team is working on and really enforce that. And if something's larger than that, obviously there's scopes of work that can take weeks or months to complete. You need to keep breaking it down until it's smaller than an agreed maximum. And that can be a generous maximum. It could be a week, it could be 2 weeks, it could be days. It really depends on your team and what they're comfortable with, but make sure that your tasks aren't too big to integrate continuously. So that's the first prerequisite. The next one is make sure your team uses source control and uses it for all code, not just code that's been finished, just all code. Even code in flight should be tracked in source control. This is the easiest one to achieve, and chances are your team is already doing this, but some teams still don't do source control properly or only use it when something is done rather than also tracking work in flight. But it's really important to track all the work being done in source control, even if it's not done yet. Next, you need to implement a branching strategy, and this needs to be an agreement in the team. It needs to be a practice that's followed reliably and consistently. There's a particular branching strategy I'll recommend a bit later on, but the particulars aren't important here. What's important is you have one in place and that you all agree on it and follow it together. So there's processes that are agreed on and followed collectively. Now, the most important part of integration, and really where teams fail to get this right, is the automated testing part. Now, there are ways to do this poorly, there are ways to do this well, but it's always hard. It's always hard work doing testing well. Now, again, we need to think of the payoffs of doing the testing versus not doing the testing. If you do the testing, if you do enough testing, then your team has high confidence around code being built. If the tests are run automatically, which they always should, if they automatically run against new code, if they act as a block to new code going in, and what that means is if new code does not pass all the tests that your team has written, then that code is automatically rejected. That's a massive safety net that your team ends up with. And this is the big area where you get to have confidence around integrating new code, is in having enough tests that no matter who wrote the code, doesn't matter if it's day one of a new hire, doesn't matter if it's the most junior member of your team, you can have a higher degree of confidence from the get-go with no manual human oversight or intervention. So getting automated testing right is important. Now, when we talk about ways of testing, I don't want to get into that in too much detail today, but I would suggest that you have to test as close to the real world as possible. Some teams prefer unit testing and have things like test coverage being enforced. That has its value in some applications, but for the most part, you need to test as close as possible to what an actual user will do and see. So that means if your product, if your software is a web app, that means your tests need to fire up a browser, hit up the actual web app, have it ideally backed by a real backend, and run through the tests in that environment. When your tests are just really small and only test discrete small bits of code, they're not going to cover most breakages. Most bugs happen in components interacting together, in one system talking to another system. It's really in that detail, not particular small bits of code breaking. So really make sure your tests are covering the real world as closely as possible. The final prerequisite for continuous integration is that you have a strong peer review process. You can easily enforce this in source control. If you use GitHub or Bitbucket, they can all enforce code reviews before new code is allowed in. This allows you to do a lot of things, make sure no one's removing tests, makes sure various guidelines are followed, and it makes sure that no single engineer is across any bit of code. All code committed, you have at least 2 people looking at it and understanding it before it goes in, and that's an important thing to do in a team environment. So just lastly on continuous integration, I want to recommend a particular flow that I think is quite simple, easy to understand, and works well for most teams. This may not work for your team. There are many other models out there. Again, as we mentioned earlier, it's just important to have a branching model that you agree on. Now, my favorite branching model is a variant of trunk-based development. Trunk-based development is when your code primarily exists in a trunk, in a single continuous flow of commits and code, and any branching happens directly off the trunk and merges back in, and those branches are short-lived. So just building on what we've said today, it's really important that work is done in small chunks, and if you're following trunk-based development, it means you merge off, you branch off, you make your change, you merge it back in. So code is rapidly integrated. That helps you follow continuous integration. In a team with a high degree of confidence over their code base and over their deployment process, you can deploy straight to production from trunk. I've seen teams do this well. I've seen teams where deployments to production can happen half a dozen times a day with no issues, with no fear around them. If you're in a team or culture that's a bit averse to that level of agility, or you simply have processes that must be followed for any new code or version, that's okay, you can still follow this methodology. The change you have to make there is anything going into trunk, into your main branch, should commit to a pre-production environment, should deploy there automatically, and then what you end up doing is at some point you take the latest version of trunk, you branch off, you do whatever manual processes are required. So that could be user acceptance testing, it could be very thorough QA, it could be approval by various business stakeholders, whatever it be. You can then do that against that snapshot. When you're happy with it, you deploy that to production. Next, I'm going to talk about continuous deployment. Done poorly, deployments can take hours or even days. They're also scary, they're fragile, they involve downtime, so your services or application are unavailable during a deployment. And finally, they involve manual processes. They are not automated. Now that's how you do deployment poorly. When you do continuous deployment, Deployments should happen rapidly, ideally in a few minutes, depending on the nature of your service or product. That may not be possible, but it should definitely take less than an hour. It should be completely automated, and it should be robust and repeatable. Anytime a deployment's made, you should be confident that deployment will end up in the environment it's meant to. You don't worry about things breaking when that happens. You just push the deployment, it's going to happen. There's no concern, there's no worry about it. That's how we do things right. Now, achieving continuous deployment should actually be a lot easier than continuous integration. The reason for that is modern cloud products can automate the hardest parts of this in terms of zero downtime, in terms of rapid deployment, and having health checks, having things like services automatically spinning up if they go down, having blue-green deploys. There's all sorts of things that can go on automatically without your team having to worry about them directly. Now, before we can get to continuous deployment, we do have some prerequisites. The first prerequisite is that you do continuous integration. And mostly I want to emphasize the testing point. If you don't have enough testing, continuous deployment is not really an option. You can't have things deploying unless you're confident they won't break things. That's where the testing comes in. Now, it's important to note that modern cloud products really make it easy to do continuous deployment. No matter what the configuration of your application is, there are ways to easily deploy it, easily manage it, and easily roll back if something goes wrong. So continuous deployment is generally an easy thing to achieve if your team is already integrating well. Some of the other prerequisites you need is version control around as much as possible. Ideally, that means your database structure, any database changes can automatically be deployed as well. Also, your infrastructure itself. And this may be difficult for a team that's never done it before, but it's worth noting that you can document your infrastructure as code, you can update it as code, and that really lets you take continuous deployment even further, where not only can you deploy a new version of your application easily, you can also update your infrastructure easily or create a new version, a new environment for your application easily as well. And that's really the final prerequisite, is actually that you have more than one environment to deploy to. If you can only deploy to production, that's terrifying. But if you can deploy to a development environment, you can deploy to a staging environment, you can deploy to a user acceptance testing environment, and those environments closely mimic or are nearly identical replicas of production in all ways but the data and maybe some of the external provider integrations, then your team can be very confident about your deployment process because they can do it in other environments first that closely mimic production. So as with continuous integration, when it comes to continuous deployment, I'll just make some high-level suggestions here. First of all, use Git. I believe it's by far the most powerful source control platform out there. I prefer using GitHub over any other Git repository sort of product. The reason for that is I believe it offers the best user experience and also the most amount of easy integrations with other products that are relevant to your development experience. So Git and GitHub. In terms of a build pipeline, a deployment pipeline, use whatever works for you. There's GitHub Actions, there's Circle CI, there's BuildKite, which I'm very fond of. But really just use whatever works for your team. The important thing is what your pipeline does, and it needs to obviously run your test automation. If you have a whole suite of tests but they're not run automatically, you're really losing a lot of the potential value in having those tests. So first thing you want to do with your pipeline is run your tests there, and those need to act as a gate. If they fail, deployment does not happen. The other thing you'll want to do is some level of static code analysis. That can be as basic as linting and enforcing rules your team agrees on. It can go further and do code quality checks or security checks as well if that's important to your team. You can also automate those in your pipeline. And then finally, you obviously need to do the actual deployments. Just on that, there's at least two things most teams will concern themselves with when it comes to a deployment. The first is the obvious one, where new code needs to be deployed to the service running it. But the other one that's a bit lost or teams ignore or don't do or think is too scary is database migrations. Now, depending on what sort of database product you're using, this may not be relevant at all. If it's a document-based store, for example, but if you're using something that's SQL-based, no matter what language you're using, there are ways to easily version your database to migrate it automatically, and that work is best done in your pipeline as well. If this video has made you realize that your team needs to prioritize CI or CD more, then just realize that you can work towards the best version of those processes. You can make incremental changes to get there. If you have any specific questions or comments, just leave a comment below. If you like this video, please like and subscribe, and I'll talk to you next time.